Guys, we're back with the notes for 2.1. We're going to be starting our functions unit. So today we're going to go through all the function vocabulary that's important for you to know and all the different tests you're going to have to be able to decide in order to answer the questions you're going to see, okay? All right, let's go ahead and look at a couple vocab words first. Our first vocab word is a relation. A relation is a very general term. It just means a set of ordered pairs. So you might have 1 point, 1 comma 2. You might just have one dot on a graph, 3 comma negative 4. Whatever you have, it is a set of ordered pairs. It doesn't matter if it's 1 point or a whole graph made up of several points. A relation is just a set of x's and y's, or a set of ordered pairs. Okay? Our next vocab word is going to be domain. Hopefully you've heard this word before, but domain means the set of all x values. Now, we're going to have a lot of other words that mean x's, and it's important to remember all of these because the question might say, what is the domain? But the question might also ask you about the independent variable. Okay, so the x value is the independent variable. It stands alone. The x I can control. It is not controlled for me. Okay. The next vocab word you're going to need to know is that it is also the input of a function, just like a machine. If I input $1 into Coca-Cola machine and I get out a Coca-Cola or a Diet Coke or a Sprite, whatever I ask for, I have to put in my money in order to get an output. Okay. In real world situation, we always call our x like the cause. Kind of like cause and effect, the cause. The x controls what happens. It is the cause. All right? So our next vocab word is going to be range. Range is the opposite. So if domain is x, that means my range is all of the y's. If my x's are independent, then that means my range or my y's, those are my dependent values. They are impacted. So if I change something on the x, my range or my y's depend on that, so they change accordingly. Just like we said with the Coca-Cola machine, whatever I put in for my dollar amount, what I get as my output is the range. So my y's are the outputs in the function. Okay. Finally, the partner word for real-world situations, we would call that effect. If the x causes something to happen, the y is the effect that takes place. Okay. You can pause the screen for just a second if you need to. Copy what you see. We're going to scroll to the next section. Great. All right, so the next thing we're going to talk about is how to test if something's a function. The definition of a function, so I'm going to highlight that word. Definition of a function is that it's a special relation where every x has exactly one y. I want you to put a little star on this that says memorize. That is going to be a question on your test. If you do not have it word for word, I will not give you credit for that, okay? So if it asks, a function is a relation who or relation where, you need to be able to say it's every x has exactly one y. You need every single part of that sentence, okay? All right, so here's how we check that. First thing we could check is, do the x's repeat? It is only a function if the x values do not repeat. So that's how we're going to check like a table or a set of ordered pairs or a mapping. We'll get to those examples in just a second. But all you need to know is it's important that the x's don't repeat. Okay? The second way we can test if something is a function is to use our vertical line test. Okay? I think you guys have seen those before, but basically we hold our pencil up and down like a vertical line. We slide it across the graph, and it is not allowed to touch more than once. So maybe we put a note on here. Can't touch twice. All right. Pause that for just a second. Finish writing what you see, and then we're going on to the last section. All right, so our last section is all about our types of data. So we have two types of data. One is called discrete, one is called continuous. Discrete is a function where the points are not connected. So one more time, they are not connected to each other. If you were to graph it, it would really just be a bunch of dots or a bunch of points. You have individual dots on your graph. Okay? When we list those for my domain and range, we're listing what the x's can be and we're listing what the y's can be. And we're going to use these little symbols. These are called braces. Okay, so we're going to put them in braces and we're going to list them least to greatest. You guys are going to see that in just a second on the examples. The other kind of data is continuous. So continuous is a function where the points are connected. So that might look like something like this. It might look like just a line. It might look like a squiggle. But anything where you could trace it with your pencil and not pick your pencil up, that means they're connected. That's continuous. Okay? So discrete and continuous are also vocab words we're going to want to know. All right? If you need to pause the screen, copy anything else, do that. We're going on to some examples. Great. All right, so we're going to look at the top. So how do you test if you're given an ordered pair, a mapping, or a table? We're going to list out our domain and range, and we're also going to decide if it's a function, okay? I'm going to do function stuff in green. Domain, I'm going to stay pink. Range, I'm going to stay blue, okay? Let's go through each of these first of all and check if they're a function, all right? So if I look at the first problem, I'm checking out all of the x values. Remember that in a point, we are x comma y. So if I look at all the x's, are they different? Yes. So when I answer my question, is this a function? We would say yes. X's don't repeat. All right. If we go to this next part, I'm looking at all of my mappings. Okay, so we're on the mappings one right now. When I look at a mapping, the first circle is my x's. The second circles are my y's. So when we're checking to see if it's a function, we're really just following the path, okay? So I see 0 has a -3 as his partner. 1 has a 2 as his partner. 3 has a 4. All right, all the x's so far are different. 5 has a 9. I only used each x once. So is this a function? Yes. X's don't repeat. Okay, none of the arrows repeated on that one, so my x's don't repeat. All right, let's look at that part for the very last one. So we're over here on the table. All right, on the table, I'm checking out all of my x's, so all the numbers here. Are any of them repeated? We would say no. So in this problem, if I had 2 zeros or if I had 2 4s, that would not be a function, but for right now, we're still good. We would say yes. X's don't repeat. All right, let's go ahead and start talking about domain and range now. So remember, whenever you are looking at an ordered pair, a mapping, or a table, because you can only see individual dots, when we say our domain and range, we're just listing out what the x's or the y's can be. Let's look at domain for the ordered pair first. We already underlined all of our x's. We're going to wrap them in braces, and we're going to list them out from least to greatest. So my first x was a 0. My next x was a 1. Then a 2. And finally a 3. All of these are my x's. Let me make them pink so you can see them. These are all my x's. Okay? So that means that the other numbers, let's make them blue, all those other numbers, those are going to be my y's. That's my range. So I'm going to put them in order least to greatest. Make sure we're paying attention to least to greatest. The lowest one I see is the negative. So we're going to start with a -5. The next one is a 2, and then an 8, and then a 10. It does need to be in order least to greatest. Okay? All right, let's do the same thing for the mapping. We're talking about our x's and y's, listing them least to greatest. So these are all grouped up for me. So remember, x's are in the first circle. We list those out. We're going least to greatest. So 0, 1, 3, 5. They are already in order for me. Same thing with the range. That's going to be my second set of numbers. It's the ones on the right-hand side. If I list them, they are not already in order. So make sure we're really careful here. We're going from a -3. The next number is a 2, all the way at the bottom. Our next one is a 4, and then the 9 is the greatest. Has to be least to greatest. Perfect. Last one of these. So x's and y's. The x's are my domain. The y's are my range, so my x's are going to go first. Listing least to greatest, they're already in order. 0, 2, and 4. I'm putting commas in between those guys. And finally, my range. So my range is all of the y numbers, and they're in order for us also. So we're going 3, 6, and 12. Take just a second, go ahead and write those down if you have missed anything. Pause it if you need to. We're going on to the last set of examples. Great. All right, so in this section, we're all about using the vertical line. I want to go ahead and show you what that vertical line looks like. Let me make it a fatter line. So vertical means straight up and down. Here's how the vertical line test works. If I slide it, let me make one for my next guy. If I slide it across the graph and it ever hits the graph, and by graph, let me show you what I mean. I mean if it ever hits what's drawn on the coordinate plane. So the graph is not the like squares, okay? That's my coordinate plane. The graph is whatever image is drawn on top of it. It's the yellow part, okay? So if I line this across right here already, I notice that it's hitting two different places. It's hitting right here and right here. So if I say, is this a function? Our answer would be no. It is not a function. Okay? All right, let me make a couple of these, one for each row. All right, so if we go to our next problem, I'm going to grab my vertical line, slide it across graph number 2. All right, I'm only hitting one spot on the yellow, only hitting one spot on the yellow, only hitting one spot. All right, this guy's all good. So I would say this one is a function. Let's look at number 3. If I draw my line across, he's only hitting one time on the yellow. Still good. Only one time down here on the yellow. Ooh, okay, it's getting a little steeper, but I still only hit it one time. So this is a function. Okay, it's passing the vertical line test. It's only touching once. Let's go down to the bottom. All right, sliding across, only touching once, all the way over. He's all good. So this guy is a function. Let's check out this little one that looks kind of like a fish. The second that I get right here, he's still only hitting once. But when I get right there, boom, I'm hitting once here and once here. That's a fail. So since I hit the graph more than one time, that is not a function. Final problem. Sliding my vertical line across, I hit one time, only once, and he passes. We are all good. He is a function. If you need to take just a second, finish copying anything here. I'm going to do one example of the independent-dependent with the word problems just to make sure that you're on the same page as me, okay? Great. So final part, if you were trying to identify an independent or a dependent variable, my reminder to you is that independent is like your cause. It happens first. Dependent is like the effect. It happens second. We know that independent would be a x value if you graphed it. Dependent would be a y value. So if it says, Jamie notices she earns more money the more hours she is working. So we think about that. Would it make sense that she gets paid the money and then that makes her go to work? Is that how you get a job? They just pay you and then they trust that you'll show up and do your job? No. Okay, so instead, our money is our effect. Let me change this to blue. We don't get paid until after we work the hours. So my working hours, I have to go to work. The more hours I work, then I get more money. Okay? So I don't care if you say work. I don't care if you say hours. I don't care if you say work hours. I don't care if you say money or money she earns or just a dollar sign. Something that tells me you understand the units for each one. Okay? All right. You do not need to do the practice until we get to class. All right? So you are only doing the video. Have a great day.